Okay, welcome to section 7.2, Similar Polygons. In geometry, two figures that have the same shape are called similar. Okay, so similar shapes, basically they have the same size, or excuse me, the same shape and the same angles, but not the same size. Okay, if they were the same size, they'd be called congruent. Two polygons are similar polygons if corresponding angles are congruent. So all the angles that are corresponding are the same. Okay, so all the corresponding angles are the same, but the sides are proportional. The sides are proportional. And this is what the big thing is in this section, is knowing how to see if sides are proportional. In the diagram, ABCD is similar to EFGH. So you're looking in your book, looking at those two diagrams, the symbol with the little squiggly line without the equals means similar. Okay, so there's two quadrilaterals they have here. And they say that ABCD is similar to EFGH. That means that angle A of this one, the measure of angle A is equal to the measure of angle E, and so on. It also means that the sides are proportionate. What that means is that side AB over another side of this, well, it depends on what you're talking about. So if you go AB is compared to EF, that should be the same ratio or proportion as BC is to FG. So the side AB compares to EF the same as BC compares to FG. So here's the two quadrilaterals that we were just talking about. So the ratios of all of the different corresponding sides to each other are all the same ratio, whether it be 2 to 1, 1 to 3, or whatever. So if this was 1, this was 3, and this one was 2, then this one is 6, because they have the same ratio. 1 to 3 is the same ratio as 2 to 6. Okay, so 1 to 3, 2 to 6. All these ratios are the same. All right, list all pairs of congruent angles. Okay, so we need to know which vertices are corresponding. It looks like they're in the same location as far as the way they're situated on the page. So angle R is congruent to angle T. Angle Q is congruent to angle, let's see, Q would be to U. Angle P is congruent to angle S. Okay, remember the angles are all congruent. Write a ratio of the corresponding sides. Okay, well, if 20 compares to 16, that should be the same as 12 compares to 15. Oh, I just wrote that wrong. Let me show you. I put the 20 over the 16, so I should write the 15 over the 12. Otherwise, they are not the same. Okay, so that is incorrect. We have to put the 15 over the 12. And then the last one, we'll have to write the 10 over the 8. Now, these should all be the same ratio. If I simplified these, the ratio is this would be 5/4. This one, if I divide each of them by 3, that's 5/4. If I divided this one each by 2, that's 5/4. So, what we're getting into is the fact that the scale factor, because they all simplify to be 5/4, the scale factor is 5/4. It's whatever they all simplify to be. Okay, so here is where they talk about scale factor. When you take this one compared to this one and put them all over each other, they should be the same ratio. If that's the same ratio, whatever that ratio is called the scale factor. Determine whether the triangles are similar. If they are similar, write a similarity statement. Okay, so some of us need a little help with that, but it says find the scale factor of figure B to figure A. When they say it that way, figure B to figure A, you need to make sure that whatever B is, it's over whatever A is. Okay, so we have, looks like this side compares to 12. So we're going to put B over A. So that means 12 is over 9. Okay, the 15 and the 20 compared to each other, so we need to put the 20 over the 15. Now, if I solve this using cross products, the products should be the same. 12 times 15 must be equal to 9 times 20 if these are exactly the same fractions. 12 times 15 is 180, and so is 9 times 20, so it checks off. These two are the same. Now that also needs to be the same as 12 and 16. Are these all the same ratios? I'm sorry, 16 over 12. They are all the same ratios because if you simplified them, these both divide by 4 and give you 4/3. These both divide by 3 and give you 4/3. These both divide by 5 and give you 4/3. So the scale factor is 4 to 3 or 4/3. All right, you try this. Oh, I forgot to tell you the similarity statement. The similarity statement with this one is to actually write it down to where you have triangle such and such. So you would say in this case, KLM is similar to triangle, then you have to write them in the same order, HJG. There's my similarity statement. Okay, so that's, make sure you know how to write similarity statements. Okay, take a minute, look at this one, see if you're able to determine whether they are similar or not. Now I'm going to tell you on the first one, you should be able to do that. The second one, you are not able because you don't know the other sides. You can assume they're rectangles, but we don't know. It doesn't say that they are rectangles. Okay, so we don't know these are rectangles. If they were, then we probably could figure out if they were similar or not. But because we don't know they're rectangles, we don't know these other two sides, we can't compare them. But number one, we should be able to compare them. Okay, I'm just going to go ahead and quick do this. You can pause the video right now and come back and let me finish it. But I'm going to show you that if I'm taking, it says figure B to figure A. So we're talking B to A. So 9 over 6, is that the same as 12 over 8? is that the same as 18 over 12? If they are all the same, they are similar because all the angles are already congruent. You can see that. If you divide both of these numbers, top and bottom, by the same number and get a simplified fraction, you should be able to compare that way as well. This one is 3/2 because you divide both top and bottom by 3. This one I can divide by 4, I get 3/2. And this one I can divide by 6 and get 3/2. So they are all 3/2. So the scale factor is 3/2. The similarity statement on this one would be DEF. Let's go alphabetical here on this one. Is similar to triangle, but then I have to start with X, go to Y, and go to Z because they correspond. This is DEF. All right, it says that they are similar. If they are similar, then all you need to do is set up a proportion with the corresponding sides. Since these are similar, we can say that X corresponds to 9, the same as 10 corresponds to 15. Once I have a proportion made, since these two compare and these two compare, I can use those to make a proportion. I actually don't even need the 8 and 12 because it should be okay. Now, since they tell you they're similar, these ratios should be equal. X over 9 should be the same as 10 over 15. Cross multiply, I get 15x equals 9 times 10, which is 15x equals 90. X is equal to 6. Okay, so x is 6. The outlines of a pool and a patio around the pool are similar. So these two rectangles are similar. It says find the ratio of the length of the patio to the length of the pool. The ratio of the length of the patio is 48. The length of the pool is 32. So the ratio would be 48 to 32. If I divide both of these by 16, I get 3 to 2. So the ratio of the length of this to this is 3 to 2. Find the ratio of the perimeter. Well, the ratio of the perimeter of the patio is 2 times 48 plus 2 times 24. The ratio of the pool, or excuse me, the perimeter of the pool is 2 times 32 plus 2 times 16. Okay, so if I'm looking for this ratio, I just figure out both of them and I get, let's see, that's 96 plus 48. That would be 144. 144 over 64 plus 32 is 64 plus 32 would be 96. Okay, let's see. I believe 48 goes into both. 144 divided by 48 is 3. So I'm dividing by 48, top and bottom, is 3 to 2. Okay, so what does this tell us? It tells us the ratio of one of the sides is the same as the ratio as the perimeters, or the distance around each one. So the perimeters have the same ratios as the sides. Okay, so here's their perimeters of similar polygons. The perimeters of the triangles is the same as the ratios of the sides. Find the value of x. Okay, so that's one way we could do this. X, you could use the ratios of two of the sides. So it says here, doesn't matter which one, so 14 to 7 equals x to 9. So 7x is equal to 14 times 9, so x is equal to 18. And then it says find the perimeter. The perimeter of this one is 18 plus 14 is 32 plus, so that's, let's do this again. 18 plus 14 is 32, 32 plus 16 is 48. 9 plus 7 is 16, plus 8 is 24. The perimeter, the ratios of the perimeters of STU would be 24 over PQR, which is 48, or 1/2. There's the ratio of the perimeters. And that's it for 7.2. Hopefully that went well for you. Please read the section and see if you understood everything, and then let me know if you need some help.